Hey gang, this is Ron from ITMasterKey.com, and in this video series and course, we're going to be going through some fundamentals for IT. So if you're a beginner, if you don't really have that much experience with information technology, or if you're just trying to get a refresher on information technology, this is the course for you. So this course is going to be going over a multitude of things. So no matter if you take an CompTIA ITF Plus exam, or if you just want a refresher or just want an introduction to IT, I got you covered. So in this actual course, we're going to be going over 6 core topics. So those topics are IT terminology and concepts, infrastructure, application and software, software development, database fundamentals, and security. So let's go ahead and get into the first video. Hopefully you enjoy. If you want a full course, or if you're enrolled in a full course, I'm proud of you. But if you're looking for a full course for IT fundamentals, head over to itmasterkey.com and enroll. So this video series is just going to be the lectures. Over at itmasterkey.com, we're actually going to break it down a lot more. And it's also going to be simulations and a bunch of practice tests to get you ready for the actual exam. So you guys wanted IT fundamentals. I listened to you, so here it is. Enjoy. All right, again, the next topic in our video series and course is going to be the importance of data. Nowadays, your data is considered an asset. So your cell phone, for instance, right? Your cell phone isn't just something that you call people on, that you text people on. Your cell phone is pretty much like your digital wallet, your digital portfolio, your digital lifeline, right? Most people can't really operate without their cell phone because they have personal information on there. They got passwords, they got GPS. That's another thing. You know, most people, if you don't have a GPS, you can't get to where you're going. So that's why data has become an asset. And data is simply defined as factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. So a lot of companies, right, love your data. Facebook loves your data. Google loves your data. Instagram loves your data. The FBI loves your data. All right, so if you think that you're surfing the web or you're doing things and nobody's watching you, good luck with that. All right. Now, so a lot of people that are watching you, it may not be for nefarious or malicious reasons, but there is somebody watching you. And the reason that organizations want to watch you is because of advertising, right? So with your data, somebody can get your entire life, pinpoint your location, where you work, your likes and your dislikes. So with data now being looked at as an asset, it's super important that in a perfect world that your data is always private and always secure. Now, it's getting more and more important to have secure data and your privacy as well. Now, that's going to be up to you. We can talk about data privacy and security a little bit later on, but right now we want to just talk about data being an asset. We're going to go ahead and go to the next slide because you should understand that data is your lifeblood. With the right amount of data, somebody can literally steal your identity and become who you are. All right, so let's talk about intellectual property. So these courses that are over at itmasterkey.com, my YouTube channel, all of the things that I create digitally are digital products, right? Meaning that there's not something physical that you can touch, but it's something that you can digitally engage with. So intellectual property is super important. So that little guy on the bottom left that's smiling, that's me, should be pretty close, I think. That would be intellectual property. This entire lecture would be my intellectual property. All right. So the actual definition of intellectual property is creations of the mind, such as inventions, literary and artistic works, designs, symbols, names, and images used in commerce, also known as business. So let's talk about the differences between trademarks, copyrights, and patents. So you see my logo, and then you see some other super recognizable logos, right? So you got McDonald's, Nike, you got Starbucks. So if any of you guys have seen Coming to America, right? There's a restaurant in Coming to America called McDowell's, right? In real life, McDowell's would have probably had a problem. They would have had a problem. They didn't have a problem in the movie because it was called McDowell's. They had some different, whatever McDonald's did, they kind of did the opposite, but it was pretty much the same damn restaurant. So trademarks allows you to separate yourself from other people and not allow people to use your logo or your phrase without some kind of compensation, right? So McDonald's, everybody, no matter where you are in the world, that logo right there is McDonald's. No matter where you are in the world, everybody knows the Nike symbol. If you want some coffee, drop in the comments what the hell that lady's supposed to represent. I don't know who that lady is, or if that's like if the lady is the founder is a lady or what. I don't know what that logo represents. But if you want coffee, you know that Starbucks, the green logo with the lady in the front, is for Starbucks. So those are trademarks, right? Now copyrights. Whenever you watch a movie, whenever you go to a movie, it's usually a big warning to say, hey, FBI warning, this movie, this material is copywritten, right? So if something is copywritten, it means that you cannot copy, you can't license, you can't use that information without explicit consent from whoever the creator is, okay? So trademarks is usually logos and phrases and stuff like that. Copyrights is, hey, I'm gonna actually ask you, can I have the copyrights to this so I can use it in a movie or use it in a music video? So let's just say that in this video, I want to play The Baby or something in this actual lecture, right? Soon as I upload this lecture to the internet, I'm going to get hit with a copyright, meaning that, hey, you didn't ask this artist if you could use that music, or if I want to use some clips from a movie, I'll get hit with copyright as well. Patents. So patents, if you watch Shark Tank, right, most of the time they'll ask, hey, do you have a patent on this? And they'll say patent pending or something like that. So a patent just means that I have an idea, this is what I want to create, or I've actually created something and I want to put a patent on and pretty much lock down this design so nobody else can make and create this design. Make sense? Good. All right, so we kind of touched on this a little bit before when we were talking about data being an asset. So data, this is kind of a big thing with Facebook because, like I said, Facebook collects a bunch of your data and then sells it to advertisers. Like, hey, this guy is in a group about sneakers. He is always liking pictures about sneakers. So let me sell this data to Foot Locker and to Eastbay and to Foot Action and to Nikes, and start advertising and marketing to this guy because this is what he likes. This girl is liking pictures of Greece, and then she likes a picture of France, and then she likes a picture of Chicago, and she likes a picture of Alaska. All right, so maybe she wants to travel or likes to travel. So let's start sending her airfare and hotels.com and stuff like that, right? So it's like this says, if you ever feel like somebody's watching you on the internet, somebody's collecting that information. For example, every time you type something into Google, that is being collected and then it's being sold to businesses to retarget advertising to you. That's just, nothing scary, but that's just what it is. So if you've ever noticed that, hey, you start looking up old muscle cars, and then next time you go on Google, on the side it's a bunch of frames for 1970 Chevelles, or it's tires for 80s Trans Am or something like that, right? So they use all that to collect and pretty much build a profile on you to figure out, okay, how can we advertise to this person? Because you have to understand those big companies like Facebook, Instagram, TikTok, and a lot of those different types of social media platforms are highly dependent on advertising dollars. That's pretty much how they make their money. So they can use your browsing habits to advertise products that you may be likely to buy, improve your browsing experience. They say they improve it by pretty much showing you stuff that you're more likely to like. So if they notice, like I said, that you like cars in your Facebook feed or Instagram feed, you'll start seeing more muscle cars. You'll start seeing more mechanic hobby stuff like that, okay? And last but not least, they can create a database of customers that are like you to start advertising to them as well. Okay, this guy is 30 years old. He's from Detroit. He likes this. He likes that. He works here. Okay, I wonder if there's more people like him, or if most people that are from Detroit, if they do like this, and I kind of try and make a demographic. So, gang, I already know that you learned more than you knew about data before you clicked on this video. If you're watching this video on YouTube, make sure that you comment, like, and subscribe, because in the actual course, we're about to go into a story time and just kind of drill all this stuff home. If you want to enroll inside of the full course, you can head over to itmasterkey.com. Not only will you get lectures, but you'll get scenario questions, you'll get practice exams, you'll get simulations, you'll get a more immersive experience over there. If you're already in the course, go ahead and go to the next lecture and you'll see what I'm talking about. Other than that, I'll see you in class. Hey gang, it's Rob, and I want to welcome you to the first episode and the first lecture in our web series and course. So this course is going to be for people who want a strong foundation in IT, so the fundamentals of IT. So if you've been preparing for A+ and feel like maybe A+ is a little bit too much for you and you want a precursor or prerequisite to A+, or if you just want to get a little bit better or feel a little bit more comfortable with IT in general, this is the video series and course for you. So to knock stuff out really fast, I'm just going to make sure that you guys know that this first lecture, right? Don't get scared. Don't get nervous. Don't act weird. Just because it's some numbers doesn't mean that it's going to be difficult, right? So we're going to break down the way that computers speak, the way that computers talk to each other on the network, just to give you a good representation and a good introduction to how things work. Ready to get into it? Let's get into it. So, notional systems, right? First thing we want to talk about is binary. So binary is the language that computers speak in. Not English, not French, not Spanish, but binary. So that is the way that computers talk to each other. That's how they compute things. That's how they figure things out. So binary is a system of ones and zeros, or ons and offs. So 1 will represent on, while 0 will represent off. Real simple. If you didn't know before, binary is the language of computers. That simple. Let that sear in your brain if you didn't know. What's binary? If you want to look cool to somebody, tell somebody, hey, did you know that computers, I don't know if they'll think you're cool if you, anyway, so binary is the system that devices and PCs use to talk to each other. Ones and zeros. That is the language of computers. Sound good? Next up, so hexadecimal is an easier representation because it's less characters and less binary values than binary. If you write out something in binary, it's going to be a lot longer than if you've written it in hexadecimal. Right there is an example of hexadecimal, and an example of something that uses hexadecimal would be your MAC address, MAC, your MAC address. So your MAC address is your physical address. Let's go back. Binary is the language that computers use, right? And then the MAC address, which is represented in hexadecimal, is going to be the physical address of that computer or that device. Every device has a MAC address, and devices use binary to communicate to each other. Sound good? Last but not least is the decimal format. So a good example of decimal would be your IP address. Anything that connects to a network or anything that connects to the internet needs an IP address. Binary is the language that computers use. Hexadecimal, an example of that, is your MAC address, which is your physical address. Your IP address is your address on the network. So if you're on ESPN.com, if you're on ITMasterKey.com, if you're on Google.com, that network, those devices know where to send the information that you're looking for. Okay? So binary is what? Very good. What is a example of a hexadecimal address? Very good. What is an example of a decimal address? Very good. And just in case y'all wasn't saying that while I was asking, binary is the language that computers talk in. Your MAC address is an example of a hexadecimal address, and that's a physical address. Then in decimal format is an IP address. All right, so that IP address is a version 4 IP address, which is represented in decimal, while a version 6 IP address is going to be presented in hexadecimal. You don't need to know that per se, but that's just a little bit more info for you. All right, so before you watch this lecture, you probably didn't know any of these things. Now you do. Pat yourself on the back. You should be proud. All right, guys, so in the next episode of our video lectures and our video course and our full course, we're going to be talking about data types. So there are 5 common data types. In this quick lecture, we're going to go over those data types. Then we're going to go through a small practical exercise if you're inside the course. If you're not inside the course, then you need to head over to itmasterkey.com and enroll inside of the course. And then after that, we're going to go through a quick little quiz. Let's go ahead and get into it. All right, so data types. So the first data types are going to be character or CHR. So characters are fixed length fields. It can be letters, numbers, or other characters, as long as they're supported in whatever database that you're using. Next is going to be strings, which is just a sequence of characters or numbers, or a sequence of characters and numbers. Next up is integers. So this data type represents a range of mathematical integers and are represented as a group of binary digits called bits. So quick quiz. In our first lecture, in our first video, we talked about binary. Do we remember what binary is? Of course you do. Binary is just simply the language of devices. It's how that computers actually talk to each other, the ones and zeros. Next up is floats. These are used to represent high precision fractional values. Last but not least is Boolean. I don't know why I said it like that, but Boolean is true or false values. So the 5 data types are character, strings, integers, floats, and Boolean. So be proud of yourself that you just learned 5 new data types that you didn't know before. So when it comes to storage is a really big deal. You know, how much stuff can I save? How many videos can I save? How much music can I save? So on and so forth. Now, you know, when computers first came out, don't quote me, but I want to say one of the first computers only had like either 512 megabytes or kilobytes. And pretty much it was like nobody's ever going to need more space in that. Nobody's ever going to need more space in that. But now that we got HD movies, we got video games, we got all this different stuff, you need more and more space. So most phones now are at least 60 to 128 gigs, right? So we said that we were talking about kilobytes and megabytes, but most phones now have way more space on your actual cell phone, and then most PCs and laptops have at least 500 to a terabyte, if not more. So, but most PCs and laptops, you're going to be hard pressed to find a new PC or laptop without 500 gigabytes of space minimum, because, well, like I said, everything going on and file size is getting so much bigger. If you have anything less than that, you're going to run out of space really fast. So, real simple, going down the line, the smallest unit of data or the smallest storage unit is going to be bits, right? There's 8 bits in a byte. There's 1,024 bits, 1,024 bytes in a kilobyte, 1,024 kilobytes in a megabyte, 1,024 megabytes in a gigabyte, 1,024 gigabytes in a terabyte, then 1,024 terabytes in a petabyte. So we also have zettabytes, but you don't have to worry about that now. But terabytes is pretty much what you're going to see Now, as far as for home computing, if you have a petabyte, I mean, hey, you can do what you want to, but if you have a petabyte, that's kind of doing a ridiculous, that's doing a lot, especially if you just movies and stuff like that. But hey, who knows? Like I said, with the more higher resolutions, with the more in-depth graphics, with the bigger file sizes, maybe a petabyte one day is going to be no big deal. But right now, it's still pretty impressive, right? But right now, a terabyte should be a couple terabytes, because the laptops that I have, most of them all have a terabyte, and then the PC that I have has 3 terabytes, and that's doing pretty good. But like I said, you know, I have external drive and stuff like that you can definitely fill up a terabyte pretty easy, right? Pretty easy. So over time, if you don't delete stuff, if you're not paying attention, you can definitely fill that up. But this is pretty much just from the smallest to the biggest storage units, how big. So we start from bits and go all the way up to petabytes, okay? And if you're in the course, we're actually gonna go through a practice quiz to drill this home, to make sure that you fully get what you need to get. If you're watching this on YouTube, no big deal. Just make sure that you are aware of these different sizes. If you knew this, great. If it's a refresher for you, no big deal. If you've never seen it, just make sure that you drill this in your head. But like I said, if you're in the course, which you should be, make sure that you drill this down pretty good, okay? All right, now we're gonna talk about throughput. So throughput is important when we're talking about internet, especially with what we're going through as far as the C word. Everybody, or a lot of people, had to transition working from home and also getting educated from home. So your internet speed was super important. If you were using a kilobit internet, I feel sorry for you, because that's actually like dial-up internet, and it's pretty slow. And most websites, it's going to take forever for those to load. So just understand that throughput is pretty much how fast data can travel. All right, so how fast data can travel. All right, so how fast it takes for something to be processed. Right, so we got megabits per second and we got gigabits per second. Now the internet connection that you're probably using right now is megabits per second. When we get into the gigabit speeds, then we're talking about fiber. All right, so most of the time, and terabit speed is super crazy fast, right? In local neighborhoods, you're not gonna really find that. You can find gigabit speeds. It's not as wide as megabits, but newer neighborhoods and stuff like that have gigabit speed internet. But for the most part, most of you guys are probably using megabits per second, which is pretty fast, which is fast enough. The internet that I'm using at my home and in my office is not the office. No, at the office it is gigabit. No, I think about it. At the office it's gigabit, but right now I'm at home. It's megabits, right? So you got gigabit, super fast. Terabit is that's just pretty much before you even think about damn clicking it, it's already popped up on your screen. It's just lightning crazy fast. Okay. All right. So last but not least, processing speed. So let's say sometimes it's kind of hard to figure out, damn, what kind of computer do I need? So we figured out the storage. Okay, we figured out, okay, probably 500 gigabytes to a terabyte, preferably a terabyte of storage. What's the next biggest thing? So the next biggest thing is going to be processing speed of your CPU. If you have a CPU that is measured in megahertz, that's a really slow processor, right? So we want to make sure that it's in gigahertz. The more gigahertz, the faster the processing speed. All right, megahertz, no bueno. Gigahertz, great, but we want to make sure as many gigahertz as possible, pretty much so it'll be sustainable, right? So it's going to be good right now, and then as new technology comes out, as new things come out, as you're trying to add stuff to your laptop or your PC, it'll be able to handle all those extra processes. But at the same time, I don't want you spending 30 grand on a damn laptop, but just make sure it has enough gigahertz to do whatever you're trying to accomplish. Hey gang, it's Rob once again, and in this video lecture we're going to be talking about input and output devices. So in our last couple of lectures we talked about binary, we talked about data types, In this lecture, we're going to talk about different types of devices, what would be considered input and what would be considered output. Let's go ahead and get straight into it. Since you guys are super smart, I'm pretty sure that you will be able to look at the things on the left and the things on the right and understand why the things on the left will be considered input, while the things on the right will be considered output. So I'm gonna give you some time to dwell on that, and then we'll talk about it as a family. All right, enough time. So a keyboard is considered an input device because you input stuff. So you type out your name, you type out a calculation, you type out whatever you want to type out, and you input that, and you give that information to the device, your cell phone, whatever it is, right? Go to the next one. So pointing devices, your mouse. So your mouse, you input clicks, and the computer gives you feedback. You input something. Scanners, put the stuff on the scanner glass, then it scans that information into your device. Microphone, you put audio into the microphone, and it takes that and puts it inside of the computer or the device, whatever you're using. And on the inverse of that, a speaker would be output. So the microphone, you input your stuff, and then it comes out of the speakers. Display devices output an image. Printers output papers or whatever else you wanted to print. Make sense? Very good. Of course it does. You guys are super smart, so this is too easy for you. So look down this list. These will be considered both input and output devices. Okay. So a flash drive, you can put stuff and save stuff on the flash drive, and you actually take stuff out of the flash drive as well. Okay. External hard drive is just simply a hard drive that's outside of a computer or stuff like that. So it's an external hard drive outside of the computer case. So you can put stuff on it, save stuff on it, or take stuff off of it. All the rest of these are the same. So a CD, put stuff on, take stuff off. Network attached storage, or NAS, is simply just a hard drive or a server that's attached to the network, and that you can save stuff to it or take stuff off of it as long as you're on that network, as long as you're connected to that network. Memory card, same thing. Mobile media players, smartphones, and fax machines. All of these devices, you can put stuff on it or you can take stuff out. Make sense? Of course it does. Hey gang, you just learned, or you just reinforced different input and output devices. So our second domain is going to be infrastructure. So how things are set up from the foundation all the way up to the most complex parts of an organization, a network, so on and so forth. So you got a lot of information in the first domain, and pretty much the stuff that we talked about in the first domain, this is just going to build on that stuff. So you ready? Let's get right into it. All right, gang, in this episode of our web series and lecture, we're going to go over input and output interfaces. We're going to talk about a little bit of networking and a couple different ways to install different types of devices. Let's go ahead and get into it. So in networking, right? A long time ago, if you use AOL when it first came out, 9 times out of 10, you were going to be using dial-up, meaning that you were getting on the internet via your telephone line. And if you use dial-up internet, the little connector, the little plastic piece on the end of that was called an RJ11. Now, most days, or most people, if they're using internet now, I hope, fingers crossed, if you're still using dial-up, God bless you, but most people now are using Ethernet, and that is a picture of an Ethernet cable at the bottom of the screen, and that little connector on the end of there is called an RJ45. Now with networking, we got a couple different ways to actually connect to things and send information, right? So 2 things that are a little bit newer and are pretty much on most devices and most cell phones for sure is Bluetooth. So Bluetooth, just like that little thing in the top right corner, if you turn that on, you can send things wirelessly, or you can use devices wirelessly, right, through Bluetooth capability. Now, near field communication, or NFC, is a proximity technology. So you can use that for payments. So if you got like Apple Pay or Google Pay, if you have an NFC enabled device, whether that's your cell phone or tablet, you can actually wave your smartphone or your cell phone up against a payment register. It's pretty much at every store or places you go, whether it's Walgreens, the mall, McDonald's. You can actually use NFC, near field communications, and just wave your device up against the payment kiosk, and it'll actually take the payment out. Okay? All right, so here's a few peripherals. All right, so peripheral is a big ass word. It just means that stuff that's outside of your laptop, right? So a printer would be a peripheral. A scanner would be a peripheral. A mouse would be a peripheral. A keyboard would be a peripheral. A mic would be a peripheral. All right, so just the additional attachments, the additional devices, just remember that those are peripherals. Now, this list is just a couple different peripheral connection types and technologies. So FireWire, you only find that as much. Some cameras still use a FireWire connection, but mostly FireWire has been replaced by USB. Most devices are USB. FireWire, like I said, is used on some cameras, but for the most part, it's been replaced by USB. Another one is a Thunderbolt, and that was introduced as a much faster way to transfer data, download stuff, so on and so forth than USB. Then, like we were talking about in the previous slide, you have Bluetooth. That's another way that you can transfer data. One very old way that we used to transfer data and stuff like that, or use devices, was RF. Now, RF is still used, and one of the biggest things that you probably used before is a remote. All right, only thing about RF or radio frequency, it needs a line of sight, good line of sight, to actually be able to not block that signal, right? So it needs a clear path in between you and whatever it's trying to point to. Now, even most remotes use Bluetooth, right? So if you got a Fire Stick or you got some kind of other remote, a lot of times, or if you're using anything, it's probably going to be Bluetooth if it's a newer device. Make sense? All right. All right, gang. So as far as those peripherals, right? So let's say we got some new speakers. Let's say we got a new mouse. Let's say we got a new printer. There's different ways to install those peripherals, right? So the old school way, a lot of times would be they would come with an installation CD. You pop the installation CD in there, next, boom, you have your device installed. But most devices now are plug and play, which means that the drivers are actually on that device. And all the driver is of some software that actually tells the two devices, hey, I'm a computer, you're a keyboard, this is how we work together. One more time, a driver is just a software that tells the two devices how to work together. So just like the installation CD, it had drivers on it to make that happen. But now, just to make things simple, you plug it in and it'll usually pop up with a notification, hey, this device is installing, hey, this device is installing drivers, so on and so forth. Some other devices, it may be IP based. So we're going to get into IPs in a few lectures, but just really quickly, an IP is just your address on the network. So you may have to put in your IP address to either configure the device or to make the device work or work a little bit better. A web-based configuration just means that we may have to go on a website, we might have to go on a portal and set some stuff up. All right, gang, so in this episode and this part of our video series and course, we're going to talk about internet service types. Let's get straight into it. So as we talked about in previous lectures, we got a couple different ways to get on the internet, right? So we got telephone, which is dial-up. It's kind of old. If you still got dial-up, hey, no judgment here, but it's going to be rough getting on YouTube. It's going to be rough doing anything that is enjoyable on the internet, right? So most people now have Ethernet. So Ethernet is pretty much the standard for most people. You're probably connected with an Ethernet cable to whatever device, or your router is connected to a Ethernet cable, so on and so forth, right? So one thing that we haven't covered yet is fiber optic. So fiber optic is super fast internet, right? Super fast internet. You can get up to gigabits per second on a fiber optic network. Now, a lot of newer neighborhoods and things like that have fiber optic going to homes, but most of us live in places where we don't have fiber optic capabilities, right? So going from slowest to fastest, dial up, of course, slowest, Ethernet, pretty good, and fiber optic is going to be super duper fast, right? So we already talked about Bluetooth and NFC. So let's talk about Wi-Fi. So with Wi-Fi, you got access points. It's just a wireless network. So if you want to walk around your house, if you want to have your laptop on your back porch, you can rock out on your front porch. You can have internet access wherever you are, or if you're in a coffee shop, or if you're at McDonald's, you can have that access through Wi-Fi. Just in case you missed the lectures before, you need to watch this whole damn video series. But in case you missed it, or in case we need to brush back up on it, Bluetooth, simply put, is just a wireless ability to send data or just to connect devices without a wire, right? So you can use Bluetooth. NFC is usually used for payment. So you can use NFC to pay for something with proximity. So if you have NFC enabled on a device or on your phone, and you have your credit card tied to it, or your PayPal or something like that, you can use that at a McDonald's, you can use that at a Starbucks, and you can use that device to actually pay for whatever you're trying to pay for. Now, with Wi-Fi, you're good, right? Most times you're good. It's not dependent on you being directly next to the access point, or being directly next to the router, or being close to wherever the actual signal is coming from. Now, of course, the closer you are to the signal, the stronger your internet and the faster your internet is probably going to be. But something else that people have is called satellite internet, right? Now this is kind of like if you have no other option, right? No other option. You know that nobody else is messing with you. You can't get Verizon, you can't get Comcast, you can't get Xfinity, you can't get nothing. You got to get this satellite shit, right? That is very dependent on something called line of sight, meaning that you have to be properly aligned and not have any obstructions in between you and the satellite. And that means any damn thing. So if it's some trees in the way, you're either gonna have a bad connection or no connection. If it's a cloudy day, bad connection, no connection, so on and so forth. So without line of sight, you have a pretty rough day. And even if you do have good line of sight, it's not going to be that fast, because it takes a long time for the signal to bounce from you to a satellite that's, I don't know, millions of miles away, or how far it is in the atmosphere. So satellite is kind of like a, I gotta have it, and honestly for that, it would just be, hey, I'm gonna send these emails, hey, I'm gonna do something. You're not about to be browsing, you're not about to be doing nothing extra, you're not about to be watching Netflix or YouTube or none of that. Hey gang, in the next episode of our video series and course, we're gonna go through a really quick lecture about computing devices and the IoT, or Internet of Things. Let's go straight into it. So IoT, simply put, is the devices that connect to the internet and all the other devices that it may be connected to. So in 2020, pretty much everything is smart. Everything can connect to the internet. They have refrigerators, home appliances that can connect to the internet. It'll tell you when you're running low on milk. It'll tell you when something has expired. It'll actually, some of them are actually connected to different stores, whether it's Amazon or Kroger, and it'll actually order the food for you, and it'll be at your doorstep. But some of these are the list of devices that would be considered part of the Internet of Things family. So like I said, home appliances, we got smart washers and dryers as well, home automation devices, things that refrigerator would be considered automation because it automatically, that's all automation is, when it does something automatically without any intervention from you, right? So it'll order the milk, it'll order the eggs, it'll order whatever you need, and it'll show up at your doorstep. You got thermostats. You got thermostats to where you can have an app on your phone. You can turn the temperature up, turn the temperature down, or if you forgot to turn the heat off, you forgot to turn the stove off, you can turn these things off through the Internet of Things. Security systems, we pretty much know that. You can lock the doors, unlock the doors, make the alarm sound, look at the webcam through your cell phone or through other devices. Monitoring cars, that's another thing. As far as Tesla has what is it called? I want to say it's called valet, where the car will come to you. It'll park itself, and there's a lot of other cars as well that'll do that now. I can't think of nothing, but Tesla is what's coming to mind right now. IP cameras, we already know what IP stands for. It's just IP addressing. So when I was saying those security systems, that would pretty much, a security system would be part of the IP cameras, right? So you can actually look at things. Streaming media devices, so that's Fire Sticks, that's things like that, right? Medical devices, that's another thing that is a part of Internet of Things, whether it's something personal, where it's maybe something that monitors your insulin levels and say, hey man, it's time for you to take your insulin, or it can actually send a notification to your doctor like, hey, this person's heartbeat is irregular, so on and so forth. But the Internet of Things, it makes your life easier, right? A lot easier. Now, when we get into more difficult courses or more complex courses, we'll talk about the security aspect that needs to be a part of all these things. So you don't only have the convenience, but you also have the security. But we're actually going to touch on that a little bit later in this course. But if you want to get inside of a cybersecurity course, you know where to go. But real quick, like I was saying, Internet of Things, there's going to be a list of things that we're talking about. What's something else? In the comments, drop something else that would be part of the IoT or Internet of Things, and tell me what it does and why you think it's a part of the Internet of Things. All right? All right, gang. So, hey, gang, in this episode of our video series and course, we're going to go through networking concepts. So, real simple overview, right? What is an IP address? An IP address is your logical address on the network, meaning that you can't actually touch it, you can't feel it, but it's your address. That's the address that the network is going to use to figure out, okay, this is where this email is supposed to go. This is where this information is supposed to go. So an IP address is your logical address on the network. And just remember, every device, cell phone, game console, refrigerator, washing machine, thermostat, anything that connects to the internet is going to have an IP address. It's your logical address on the network. Same thing with the MAC address. The logical address is your IP address. The physical address of the device is going to be your MAC address. IP address, logical address, physical address is your MAC address. Every device has a MAC address. Every device has a MAC address. All right. Every device has a MAC address. So if the device can connect to the internet, it needs an IP address, and it also needs a MAC address. The MAC address is from the manufacturer. The MAC address is from the manufacturer. All right. Just want to make sure you guys understand that. So here's a couple of different devices that we're going to be talking about as far as networking goes and stuff like that. A router. So a router is what's going to get you on the internet. So your router takes you from your local network onto a bigger network, from your local network onto the internet. And your router is going to use IP addresses to figure out where things go. Oh, let me send this here, let me send that there. Okay. A switch is going to be used inside your network to connect multiple devices together. So router is from network to network. A switch is used inside of a network, and a switch is going to use the physical address, your MAC address, to forward information to figure out where stuff goes. Okay? Access point. So we already talked about Wi-Fi, stuff like that. So if we have a router, if we have a big area that we're trying to pretty much extend coverage to, we can have our main router, and then we can have access points that is connected to that router, right? So we can pretty much expand the coverage so we can make sure that we have a wide area of coverage, right? So we can have an access point downstairs, an access point upstairs, or we can have an access point in HR, have access point in finance, so on and so forth. So access point gives people access to the network, and it can extend the coverage of a network. A firewall, simply put, it can permit or deny certain traffic. So we're talking about where does stuff go, routers, switches, this stuff sends stuff here, this thing sends stuff there. A firewall can actually stop stuff like, hey, I don't want this to come in, whether it's going from rules that you set up or it's rules that the organization set up. It can permit or deny. So a firewall just stops stuff, or it allows stuff to come onto your network. All right, so network communication, we talked about local and we talked about the internet. So local area network is your local network. Your LAN is your local network. If you at home, that is your local network. If you at work, that is your local network. As soon as you leave that network, right, you go through the router, you go to another network, you are on a WAN. A WAN is a wide area network. The internet is a WAN. The internet is just a huge collection of interconnected LANs. All right, so it's connecting LANs to each other, right? So a router is your gateway onto the internet. It's your gateway to the WAN. DNS. So we're talking about the internet. DNS, or domain name server, your domain name server. We'll get into ports a little bit later. The domain name server translates a website name into an IP address. Remember, everything has an IP address. Every website has an IP address because every website runs on a web server. All right, so every website runs on a physical device, a web server, but it needs a logical address, an IP address, to be able to send and receive information. And the DNS was came up with because instead of you having to remember a bunch of random numbers, you can just remember ESPN.com. You can just remember itmasterkey.com. You can just remember google.com instead of the numbers that's related to that. Okay, if you don't know about the numbers, the ones and zeros, binary, you need to go to the first video in this series and watch it. The third domain is going to talk about applications and software. So we know in today's world, it's pretty much an app for anything you want to do. So we're going to talk about how applications, whether it's on a cell phone, whether it's on a PC, how that is actually developed, how that works, and how different software actually is compatible with certain things, not compatible with other things, and different varieties of software as well. Sound like a plan? Let's get into it. All right, so the next topic we're going to talk about in our video series and course is operating systems. So whatever you're using right now to watch this video has an operating system. No matter if it's on a cell phone, if it's on a tablet, if it's on a PC, it has an operating system. The operating system, simply put, is what operates the system. All right, let's dive just a little bit deeper into that. All right, so just like this is, operating system is a powerful and usually large program that controls and manages the hardware and other software on the computer. All computers and computer-like devices require operating systems, including laptops, tablets, desktops, smartwatches. All of those things have an operating system. If you have a smart fridge, if you have a smart this, a smart that, all of these things have an operating system. So two different variances in the operating system is the GUI or the GUI and the command line. So the GUI or the GUI, the graphical user interface, is what we're using right now. So it's pretty pictures and buttons and stuff that we can click on and graphics that we can actually see. Right now, the reverse of that is the command line or the command prompt. So everything that can be done on the graphical user interface can be done in the command line. So the command line is just words, letters. If you're using Windows, it's going to be a black background with white letters, and you have to have the proper command and the proper syntax, and you have to put in the proper commands. If you want to create a folder, you have to know the command for that folder. So instead of, if you're in Windows, right clicking, then say new folder, you have to know the actual command for that actual thing that can be executed. Okay, so real simple. Graphical user interface, graphics, stuff like that. Command line, you have to know the actual commands. It's going to be words and commands, and each one of those commands is going to execute something for you, right? So something called Linux, a Linux operating system, that was the basis of Linux. It was going to be a lot of commands, all right, a lot of words, a lot of different letters, and some people were actually scared or shied away from Linux because that stuff looks scary, looks creepy. They don't know what the hell is this. But nowadays, the Linux base, and even back then, it had a graphical user interface. So with the command line, you can manipulate things, you can move things, you can do things. And if you know exactly what you're doing, the command line can be a lot more powerful than the actual GUI or the graphical user interface. But just simply put, what I want you to get from this is, what the hell is the difference between the graphical and the command line? The graphical has graphics, pretty stuff you can click on. The command line, you have to know the commands, okay? So no matter what operating system that you're using, you're going to need a file system. So the operating system is what operates the system. Then the file system is what organizes all the files and folders inside that operating system. So once you download an operating system, you have to apply a file system. So on this slide, these are the file system by default. Depending on what you're trying to do, what your ultimate goal is, you can put different file systems on different operating systems. But by default, as of this recording, these are the file systems that you're going to get. So for example, if you have a Macintosh or a Mac, you're going to get the HFS Plus, the hierarchical file system. Linux is going to be the fourth extended file system, or ext4. Microsoft, which is probably what you guys are using right now, or maybe not, don't matter. You know, if it's Apple, Macintosh, whatever, you're going to be using NTFS for the newer versions of Windows, and you're going to be using FAT32 for the older versions. Okay, so we talked about operating systems, graphical user interface, stuff like this. There's pretty pictures and stuff you can click. Command line is the actual commands. You have to know what to type in. Then the file system is what actually organizes the files and the folders, and it has to be applied to your operating system where it won't function properly. It won't boot up. It won't do what it's supposed to do. In this episode of our video series and course, we're going to go over different types of software, mainly focusing on productivity software and some collaboration software. Okay, so a lot of this stuff you've probably used before. So productivity software, stuff that makes you more productive. So one type of software is word processing software. You've probably used Microsoft Word. You type in stuff, you might need to do a book report, you might need to do a presentation, stuff like that. So you go ahead and put your stuff in Microsoft Word. Now that isn't the only word processing software, but it's the most recognizable, right? But you can also use stuff like WordPerfect or Google Docs and stuff like that. Now, spreadsheet software, everybody's favorite, Excel would be an example of a spreadsheet. So you can make rosters, you can make calculations, and it can all be in one spreadsheet, right? So it can put in different formulas and you can figure stuff out. Microsoft Excel, like I said, is pretty much the I wouldn't say premier, but that's like the most damn renowned one that pretty much everybody knows, right? Presentation software. Now, if you've been around computers at all, you probably had to do a presentation software, whether if it was for school, if it was for a business, if it was for your job. You've used PowerPoint before, so you can put pictures in there. You can do slides. You can pretty much present the stuff in a way where people can understand what's going on. Web browsers. So a web browser, simply put, allows you to surf the web, browse the web. You can use Chrome, you can use Safari, you can use Firefox, you can use Microsoft Edge, you can use various different browsers, and it depends on which one you're most comfortable with. Most times, whichever one you use the most, or whichever one you use at first, is probably the one that you're gonna rock out with. Well, maybe not, because I started off with Microsoft Internet Explorer, and I can't remember last time I opened up Internet Explorer, or now it's called Edge. But simply put, these are really recognizable and popular types of productivity software. Now, especially since the damn C virus dropped, we're having to do a lot more collaboration and a lot more working from home, whether it's emails, whether if it's Zoom calls, whether if it's conferencing calls, but a lot of stuff you're doing from home. And some people, your kids are working from home as well. Some kids like it, some kids don't. But to me, I was talking to one of my students that was saying, my students, or not my students, my kids won't do this damn homework. They say they get bored. It's not blah, blah, blah. But it's like, hey man, if you can goddamn be on Instagram or YouTube for 8 hours, you can sit down and do some math homework or something. But that's just my opinion. But anyway, collaboration software. So emails, right? You got Gmail, you got Outlook, you got a bunch of different types of email clients that you can use, because nowadays people have 1,000 different ways to get in contact with you. It's kind of hard to say, did you miss my call? Because I text you, I emailed you, I damn poked you on Facebook, I liked your Instagram, I DM'd you. It's just 1,000 different ways to talk to somebody. Conference software. So this has seen an explosion. Zoom, stock price and everything else went up a lot because everybody is using Zoom. Another one could be Skype or Google Hangouts, stuff like that. But right now, Zoom is the most popular. Okay, let's do a Zoom. Let's do a Zoom call. Pretty much everybody knows what that means. It's just you can see me on the camera just like this, and I will see you on the camera, and we will say whatever we need to say. Like I said, a lot of kids also are getting familiar with Zoom, even if they don't want to. Instant messaging, real simple. It's pretty much like a text message, but it's going to be on your PC, it's going to be on your laptop, it's going to be in a messaging app, and you can just shoot somebody a message and then it'll get directly to them. So instant messaging, right? So Facebook Messenger, Skype, and stuff like that. Document sharing, that's a really big collaboration tool. So you guys might have a project, but the project consists of one main idea or one main document, and you can have a team of you guys work through the document together. You can have version control, which means you'll see who did what, and we can save the previous version just in case if somebody hop in there and they sleepy or they didn't have enough coffee and they mess something up, we can go back to the version before that actually worked. All right, so collaboration stuff, that's email. Email ain't working, let's hop on a Zoom call. Zoom call, your Zoom drop, so I shoot you a Facebook message, and then we all collab on a document. I see that Sarah was the last one to make some adjustments or make some corrections, so I see the stuff that she did, and then I'll just hop on after whatever she did. Make sense? Hey gang, in the last episode we talked a little bit about web browsers, so let's talk about what web browsers can actually do and a few of the extra settings and things that come with web browsers that we can actually kind of use to make the web browsers our own, make them a little bit more secure, make them a little bit more compatible, so on and so forth. Let's go ahead and get straight into it. All right, so web browsers. A lot of web browsers have a cache, right? Have a cache or use cookies, and pretty much what that is that information is saved on your hard drive. That information is saved, so when you revisit that web page, it'll load a little bit faster. So I have to load the banner, the video, the everything. Little nibbits and little kernels of the actual website will get saved. So when you bring the website up again, it'll load a little bit faster. Cookies also are used to kind of look to see what your habits are, to see what you're doing, to see what you like, what you don't like, to kind of make your browsing experience a little bit better. That's what they say. So just to make it a little bit better. Okay. Now, if you're using Chrome and other things, you can actually add more functionality to your browser. So you can add an extension. So if you're using Chrome, you can use an extension to where if you go on a website, it'll automatically apply coupons to your basket. Or you can add an extension that'll tell you what the weather is in 5 different countries. Or you can do an extension that can automatically block certain advertisements. Or you can do an extension, literally there is an extension for any and everything that you can think of, right? So they have extensions for VPNs. We'll talk about what a VPN is, a virtual private network. They have different extensions for anything you can think of, right? Now, private browsing. So whenever you're browsing, believe it or not, there's always somebody watching you. Always somebody watching you, whether it's to get your browsing habits, whether it's to see how you're actually interacting with a website or what you're doing, but somebody's always watching. A lot of advertisers are watching, a lot of marketers are watching it. If you own some weird ass websites, the FBI is probably watching. But with private browsing, it's not supposed to save any of your browsing information. No history, no cookies, no nothing. So it says leaves no trace after you end the session. Technically doesn't leave a trace, doesn't leave anything behind. So if somebody, comes and opens up the web browser after you, whatever you were doing shouldn't pop up. Now, if you're doing some weird stuff, some crazy stuff, there is ways to still recover your browsing history, and some websites, it may not work on their website as far as their private browsing. Now, private browsing is better than nothing, so you can use it, but just know that if you're doing something crazy, if you're searching some weird stuff, if you trying to figure out how the hell to build a rocket launcher, no matter what the hell you're doing, you're going to end up on somebody's list. All right, end up on somebody's list. But anyway, we'll talk about that when we get more into security. But private browsing technically lets you browse in private without nobody seeing anything. Okay. All right. So talking about private browsing, right? There's something called a proxy server. And if you use a proxy server, that can be even more in depth than a private browsing, way more in depth. So with private browsing, it's like, okay, I don't want people to know what I'm doing. I don't want people to see what I'm doing, so on and so forth. With a proxy server, you can actually ask the proxy server to go to websites instead of you. Make sense? If not, don't worry about it. I'm going to clear it up. So I want to go to weirdasswebsite.com, right? So instead of me going to the website myself, I actually connect to the proxy server. Then the proxy server connects to weirdasswebsite.com, and then it sends the information back to me. Okay? One more time. So I connect to the proxy server connects to whatever website I'm trying to connect to, and then via the proxy server, I get connected to that website. But to that website, it looks like the proxy server is the originator of the request. It looks like the proxy server is connected to the website and not me. Make sense? All right. So so let's say that I'm on a diet, right? Not really, no, just playing. Let's say that I'm on a diet, and I got a personal trainer. He like, hey man, you cannot eat any damn pizza. Do not eat any pizza. I'm like, okay man, I'm not going to eat pizza, just Brussels sprouts. And then I end up sending somebody to the store, right? Says somebody, hey man, I need a slice of pizza, man. I'm doing pretty bad. So the personal trainer is doing push-ups in the parking lot, the Pizza Hut or pizza store. Just so I won't come up there. So I'll send one of my neighbors, say, hey man, just go give me a slice of pizza, please. So he goes and gives me a slice of pizza. The personal trainer doesn't know it's me asking for the slice of pizza. The guy comes back and gives me the slice of pizza. So the next door neighbor that got me a slice of pizza would be the proxy server. Makes sense? They connected to it instead of me. We already know what pop-up blockers are. Pop-up blockers, block pop-ups, block pop-ups, right? So pop-ups are, hey, come try this diet pill. Hey, come do your taxes. Hey, come fix your credit. Hey, whatever, a pop-up advertisement that you don't want to see. So pop-up blocker does that. Now, with some websites, you actually have to turn on or turn off the pop-up blocker for it to work correctly. And a lot of times websites now tell you like, hey, you have to turn off the pop-up blocker. And some other websites, if you have like an ad blocker extension or something like that, that's going to actually block ads or actually tell you, hey man, this is how we make money. You got to turn that ad blocker off. All right. So whether it's an ad blocker or a pop-up blocker, it's going to block stuff that you don't want to see. All right, gang, so in our next episode of this video, course, and lecture, we're going to go through a really quick lecture. Okay, let's get straight into it. So we've been talking about software. We've been talking about different operating systems. So we've been talking about a lot of things. So with applications or software in general, there's two different types. So with some applications and software, it can be open source. With other things, it can be proprietary. So if an operating system or a application is open source, you can actually modify it without worrying about any kind of ramifications, without anybody coming after you to sue you. You can literally make it your own. You can change the code. The source code, we talked about coding already, is available to you. So you can manipulate it any kind of way you want to without any legal ramifications or legal repercussions, right? Now, proprietary means that the end user, you don't have access to the source code. You can't manipulate it. You can't do different things to it without getting in trouble. So, for example, Apple is proprietary. So if you change anything to the operating system, if you do anything weird, for one, it's going to void the warranty. And two, if you create something on a mass scale and make a lot of money, they're going to sue you because it says right there, you cannot do anything to their source code. You cannot change anything. The way it is the way it is. So with cell phones, there's something called jailbreaking. You can jailbreak an iPhone or an Apple device. And what that means is that you break into the source code and you change it to whatever you want to change it to. And the things that I just mentioned, it's going to void the warranty. And if you do something super duper and make a lot of money, they're going to sue you, right? So proprietary, Apple proprietary, Windows proprietary. Now Linux is open source. Linux is open source. You can do what you want to. You can rock out. You can do whatever and nobody really cares and nobody's going to say anything. Open source, you can do whatever you want to willy-nilly. Proprietary, can't do anything at all. Okay? So when you're installing applications or any kind of software or operating system, just use common sense, right? First thing, I know you're cool, I know you're super smart, but read the damn instructions, right? Sometimes it's just next, or yes, but sometimes you may have to actually set up stuff and configure stuff, and a lot of times, believe it or not, those instructions are in the instructions. Another thing is make sure that you're reading the agreements, right? Because sometimes, especially with a lot of applications, a lot of apps, cell phone apps, you may be agreeing to something that isn't agreeable, right? It may the app may have access to things that it shouldn't have access to, or you don't feel it should have access to. So just make sure that, I know it's long, but at least do your due diligence, especially for mobile applications. Because just because it's in the Play Store or the Apple Store or the Microsoft Store does not mean that it's completely secure. So you have to do your due diligence and read what the hell does this thing have access to and what can and can it not do. Can it delete my numbers? Can it delete my contacts? Can it copy my contacts? Can it call people? Can it save stuff? Can it download? You know what I'm saying? So just make sure that you're aware of that stuff. And last but not least, See what's best. Is the default configuration best, the basic configuration, or do you want to have some advanced settings in there? Do you want a specific thing to happen at a specific time, so on and so forth? And if you change from the default settings or the basic configuration, how can that actually affect your experience, and can you go back if you mess up the settings? Make sense? The fourth domain is really going to piggyback on the last domain. In this domain, we're going to talk more about how to create or develop software, when the last domain kind of focused more on how to use different software, how to interact with different applications. This one is going to actually talk about more the creation side of applications and software. You ready? Let's get into it. The next topic in our video series and course is going to be software development. Let's get straight into it. Okay, so software development. If you're using YouTube, if you're looking at this video right now, if you're looking at Netflix, you're going to be looking at code. All right, so the underlying part of that application is going to be written in code. So the coding language that it's written in is what the computer uses. It's what we use to build software and applications. So it's kind of like the roadmap. If I click this, it's going to do this. If I close this, it's going to do that. So video games are written in code, applications are written in code, software is written in code. This website that you're on right now is written in code, okay? So there's a couple different language categories. So some popular languages are Python or Java or JavaScript or C++. And each one of these different languages have different uses, different strengths, different weaknesses, and different applicability depending on what you're trying to do. So language categories, we have interpreted. So interpreted languages execute instructions directly and freely, without previously compiling programs into instructions. So just like we talked about YouTube before, Python is the coding language that YouTube is built on. Facebook is also built on Python. Compiled languages. So a compiled language is converted directly into machine code that the processor can execute. So something that the PC, something that the actual CPU can execute. So an example of that is C++, which is what Windows Media Player is run on. So C++ is used on a lot of other applications and things like that, but that's just one of the things I thought would, stand out that you would know. So Windows Media Player uses C++. Query. Computer languages used to make queries in databases and information systems. So example, SQL. So Facebook, right? So when you search for something, if you're trying to look for something, it's going to use SQL. So query is just like a question. Cat videos, you type that into the search box in the Facebook, and that's a query, that's a question. So it's going to use SQL, that language, to figure out what you're trying to ask it, right? So today we talked about coding languages, popular coding languages, Python, JavaScript, C++, Java, so on and so forth. Code, all this stuff is built on code. Website we're on right now, all the applications that you use. Code is just the instructions that when you're playing a video game, if I press X, the guy's going to jump up. Makes sense? If I am on YouTube, when I press play, it's going to play. When I press pause, it's going to pause. So all that stuff is built on code. So the fifth domain is going to be database fundamentals. So database fundamentals, whether you're using Excel or Salesforce or something else that's more complicated, a database can make your life 10 times easier. So this domain is going to cover the fundamentals of database creation and how to maintain a database. We ready? Let's go ahead and get into it. All right, gang, in our next video in our video series and course, we're going to be going over database fundamentals. Let's get straight into it. So a database is just a collection of data. So you can quickly retrieve information, you can quickly search for information inside this database. So different types of databases for different types of applications. So you might have a point of sale, which is pretty much just a database with inventory, whether it's a grocery list, whether it's different shoe sizes, but it's just a database with different types of items in it. Or you can have a booking system to where it'll be able to look up different dates, different times, different locations, and different prices. So quick class, database uses. So in a database, you can create a database, you can import or input data, you can create a query. Like I said in the last episode, a query is just a question. Hey man, what is this? Hey man, what is that? Or you can create a report. Okay, on June 1st, all these things happen. On June 2nd, all these things happen. So database is just a clear and concise place where we can search for different data, different information, put different inputs, create queries, and even create reports. So there's a couple of different databases, right? We got flat file database or relational database. So in a flat file database, none of the stuff is related to anything else. All the files are their own individual standalones. So they're not related to the other files in the database. So these types of databases are standalone, meaning none of the data has any relation or linkage to any other files. So what do we think relational database is? So relational database, all of the information inside the database is related to one another. So it's a lot more robust, it's a lot more dynamic. So this type of database uses a collection of tables that are linked to a common thread of data. A relational database is much more robust than a flat file. So advantages, you can scale it. It's a lot more scalability, so meaning that you can make it bigger, and it's going to be easier to scale it because everything is related. So once you put in a new file, it's going to relate and link that data to the other data that it would be linked to or related to, similar files, so on and so forth. Speed, it's a lot quicker than a flat file, because in a flat file you got to actually look into this folder and that folder. But with a relational database, if you search for something, the query is going to bring up all the stuff that's related to that search. And another thing, a variety of data. So you can have a variety of data, and it's going to be linked to similar data that's inside that relational database. So flat file is just pretty much standalone files by themselves. Relational database is just a bunch of files that are related to one another. The last and final domain is a super important domain because security is important for you, me, and every organization. With cybercrime and identity theft on the rise, we want to make sure that we have a good foundation for security. So with this being our last domain, make sure that you pay attention. Hopefully you had a good time. Hopefully you learned a lot. Well, I know you learned a lot. But anyway, let's go ahead and get straight into it. Let's go. All right, in the next video in our series and course, we're going to talk about the CIA triad or the CIA pyramid. Something super important when it comes to security. Let's dive straight into it. So when we talk about information security, there's three things that we always want to ensure: confidentiality, integrity, and availability. All right. So confidentiality just means that secret stuff stays secret, or the only people that you know about this stuff are the only people that know about this stuff. So confidentiality ensures data, info, services, and all the above remain hidden from unauthorized users. Confidentiality, it's a secret. Don't tell anybody else. If you have an email, the only person that should see that email is the person that you sent it to, right? Integrity. Integrity just means that the data, the services, the communication should remain the same. It shouldn't get altered. It shouldn't change at all. If you type an email, if you type something, once you send it to that person, it shouldn't have anything extra. It shouldn't have anything deleted. The integrity of information. Last but not least, availability. Things should be available to you when you want them to be available to you. If you want to go on itmastery.com, it should be available. You shouldn't be denied that service. You shouldn't be denied data. If you want an email from somebody, you should receive that email. So when it comes to information security, three things we want to really focus on: confidentiality, integrity, and availability. Now there's a couple of concerns with each one of those. So with confidentiality, you have to worry about snooping. So snooping is pretty much being nosy, snooping around, looking around, trying to figure out people's personal information, right? Literally snooping, whether it's looking over somebody's shoulder, whether if it's going through physical paperwork, if it's trying to hack into somebody's stuff, that is snooping, right? So social engineering is taking that being nosy to a way more malicious wave, pretty much. So social engineering is literally asking prying questions to unsuspecting victims, pretty much, seeming like you're just making conversation, but you're trying to get as much information as possible. Hey, how you doing? Where you work at? Oh, how long you been working there? What's your hours? Who's your boss? Oh, how is he? What about security? Is there a security guard there at night? Oh, okay. Do y'all need passwords? Do y'all need pins? Do you need it? Just pretty much asking prying information where, and some people who aren't trained or, maybe they tired that day, they may actually give up a lot of security information without even knowing. Okay. Last but not least, dumpster diving, right? So that's why it's always a good idea to shred information, to shred your mail, to shred anything that may be personal to you, because that's still a thing. People will still go through the dumpster to see if they can find any information, especially around businesses and stuff like that, because maybe the secretary or whoever is the person that's in charge of doing it may not have shredded the information. They may throw 1,000 pages of personal information, people's social security number, people's addresses, and a dumpster, thinking, oh, ain't nobody gonna get in the dumpster. But depending on what the payout may be or what the result may be from somebody stealing that, they may be extremely motivated to dive in the damn dumpster. Okay. Next up is integrity. We said integrity is we want to make sure that the stuff is the way it is or supposed to be when it gets to the receiver. So I sent it and I want to make sure it looks exactly the same way when it gets to you. So one of the attacks, or one of the ways that people can actually manipulate information or data, is with a man-in-the-middle attack. So literally, a man-in-the-middle attack is a software or device or even an actual person that is in between two different points. So I want to send something to you, but there's literally a man in the middle. So I send you an email, right? And it gets intercepted by the man in the middle. The email, when I sent it, said good morning, but he intercepts it. He changes the integrity of it. He changes it. And when it gets to you, it says, good morning, go to hell, right? I didn't write that, but that's what it's going to say when it gets to you, because he changed the integrity. Makes sense? Another attack is a replay attack. So just like a man in the middle attack, you intercept the traffic, you change it around, and then you shoot it to whoever the recipient is. With a replay attack, they usually are in the middle, but they're capturing passwords, or they're capturing pins, or they're capturing sensitive information, and then they'll replay that information later on. So they figure out what your password and pin is, and then later on they'll use that information to log into your accounts. Make sense? Last but not least, impersonation. So that's when somebody impersonates that there's somebody else. This can be in physical form, this can be through email, this can be over the phone. So right now, there's a lot going on. So, somebody may impersonate, hey, I'm the CEO of Walmart. I just wanted to see if you need anything. I know that you frequent Walmart a lot. We're actually giving out this $500 gift card. If you would just, fill out this quick survey, it's not asking too much. And then when you actually get through the survey, they got your social security number, where you live, your credit card number. We won't charge your credit card numbers for a free trial, blah, 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 blah. So on and so forth. Okay. So we went over confidentiality. We went over integrity. And last but not least, availability. So the expectation is that when you click on something, you expect for it to work. You expect for you to be able to go on certain websites, so on and so forth. So one attack or one concern is denial of service. Sometimes this is malicious, sometimes it's not. When it's not malicious, let's say that we try to buy the latest and greatest t-shirt, right? Everybody in our city wants this t-shirt. So the server, the web server that runs the website that this t-shirt is on, can only handle 1,000 requests per minute, but it's getting 10,000 requests per minute. So the server and the website crashes, thus denial of service, right? But at the same time, it can actually be an attack to where there's actually a bunch of people trying to get on the website intentionally to crash it. So when people that actually want to get on a website can't get on the website. Makes sense? So denial of service, it can be malicious where people are actively trying to break the website, or it can be non-malicious to where it's just overloaded. Either way, the availability is gone and you'll have a denial of service. Another thing is power outages, right? So if it's a power outage, the power is out. You know, the web server isn't up, or the file server isn't up, or the PC that you're trying to get on isn't up. And one thing that we're going to talk about a little bit later is an UPS. And that's what's one thing that can actually help you with availability. So an UPS or a UPS is an uninterruptible power server or system. So what happens with an UPS is that when you have a power outage, when you have a blackout, when you have an electrical surge, something that happens that knocks out the power, the UPS is pretty much like backup power. So you'll have your servers connected to that, or you'll have other really important devices connected to an UPS. So when the power goes down, those devices will still work. So you can save stuff, shut down, so you won't have complete losses or corrupted data. Okay. Last but not least, hardware failure. So things break, you know, they may be past their lifetime. It may be time to life cycle those things and get rid of those things and get some new stuff in there. So with availability, service can be denied. You might have a power outage, or stuff just might break from time to time. Okay. All right, gang. So in the next video in our series and course, we're going to talk about the AAA model. We're going to talk about authentication, authorization, and accounting, and the differences between those three. Let's get straight into it. So authentication. Authentication is just ensuring that you are who you say you are. And there's a couple different factors, a couple different ways that we can figure that stuff out. All right, so we can authenticate you through one factor or multiple factors. So example of factors can be passwords, pins, biometrics, and biometrics would just be something that you are, right? So that could be an iris scan, that could be a fingerprint scan, so on and so forth. Or it can even be a hardware token. So a hardware token can be a ID badge, an access badge, stuff like that, right? So just understand that when we're talking about authentication, it's a couple different things. Multi-factor, meaning it's going to use multiple factors from that list. It's going to be something the user is, something the user has, or something the user knows. Password, something that you know. Your fingerprint, something that you, not say that you is, something that you are, something that you is, or something that you are. Or something the user has would be an ID badge or an access badge. Make sense? So multi-factor is going to use two or more of those standards or those protocols. So multi-factor would be something that you know and something that you have. So you would use your password and you would use a badge, or it would be something that you are and something that you have. So you use a fingerprint and you would use your badge, or you would use so on and so forth. Makes sense? So understand that a password and a PIN would not be multi-factor. A password and a PIN would not be multi-factor, because a password and a PIN is something that you know. So that's only one factor. Make sense? All right, so is, has, knows. Something that you know, something that you are, or something that you have. Make sense? So we went through all authentication, proving that you are who you say you are. Then authorization is once you actually gain access, after we actually identify and make sure that you are who you say you are. So authorization is gaining access to a system, device, service, or data once authenticated. So when you talk about permissions, right? When you talk about permissions, you always want to use the model of least privilege. So there's a couple different models. Role-based access, meaning on what your role is, depends on how much permission you have. Mandatory access control, discretionary access control. What I want you to get out of this slide, though, is that no matter what you have going on, the pinpoint, the thing that you need to remember is once you become a system administrator, once you become the boss of all bosses, you need to always give people the least privilege. All right, so that may not make sense right now, but let's clear it up. So you give people the least amount of privilege to do their job, right? So if they just need read access, just give them read access. If they need complete ownership, then you just got to give them complete ownership. But don't go the lazy route and give people full ownership or full control when they don't need full control. Why is that? Why do you want to give people the least privilege? I don't think that the janitor should have the same permissions as the head IT tech. Makes sense? Because different people have different responsibilities. So if you give too many permissions to the wrong person, they may by accident delete the wrong thing, or on purpose delete the wrong thing, or move the wrong thing, or move things. So you want to always apply the principle of least privilege to minimize the surface area of attack. Meaning that, like I said, a lot of times users do things by mistake or by accident. Sometimes it's malicious. So just give people the amount of access that they need. So if they work in human resources, they probably only need access to the human resources files. If they work in finance, they probably need the access to just finance, right? Or if they need access to human resources, they probably need access to certain files in the human resource. So as a system administrator, you can create groups and then put people in groups, and everybody in that group would have the same permissions, just to kind of make things a little bit easier for you. But when it comes to permissions, don't be lazy, but always use the principle of least privilege, because it's better to give people not enough privileges and then find out, okay, maybe I need to give them a little bit more, maybe I need to tweak this, maybe I need to tweak that, than to give them way too many and they done deleted something or installed something or just did something crazy that you kind of can't come back from. Make sense? Okay. So we went through authentication, which is approving who you are, authorization, actually giving you access after we prove who you are, then accounting. So this is actually once you actually are authorized and you own access, got access, and you own the server, or you in the server room, or you own the website, or you doing whatever you're gonna do. This is actually pretty much tracking you and accounting to make sure what you're doing, when you did it. So if there's any changes, we can figure out, was it you, was it somebody else, was it a system, what's going on? All right, so accounting, like I said, monitors and tracks what you do after you've been authorized access. So with this, as far as troubleshooting goes, you can go through logs and see, okay, at 8:59 you logged on, and then at 9:15 everything blew the hell up. Let's see if it was something that you did, or if it was just something else. Then, like I said, you can actually track people too. Like I said, that's another thing. Let's say that you did give too many permissions to somebody, and they log in at 9 o'clock. At 9:05, this file disappeared. They was the only one that was logged on, so it had to be them. All right, it's pretty much deducing that, okay, it had to be you because you was the only person that was on the network at that time. Make sense? So we just went over AAA, which is authentication, authorization, and accounting. I almost forgot my damn self. No, I didn't. But this is really simple. May have seemed like it was a little complex before, but authorization, authentication, accounting. Well, actually in the reverse. Authentication, authorization, and accounting. Authentication, you are who you say you are. Authorization, let's give them access to what he supposed to have access to. Accounting, let's look at what the hell you're doing after we actually gave you access. Hey gang, so in today's video, we're gonna go over encryption. Let's get straight into it. So there's data in transit and data at rest. Data in transit would be emails, right? And data at rest would be something like your hard drive. So data in transit, stuff that's moving across the network, stuff that's actually moving, stuff that's actually in motion, stuff that's getting uploaded, stuff that's getting downloaded. At rest is just the things that are on your actual hard drive, stuff that's not moving right now as we speak. So if it's data in transit, we can actually encapsulate and encrypt that information, meaning that it shouldn't be able to be read by anybody other than the recipient. Nobody should be able to peek in and see what we're doing. We can also encrypt the data that's at rest. We can encrypt the entire hard drive, or we can actually encrypt certain files and folders on that hard drive. And just so we understand, encryption just means that you make the information make the data unreadable to people that shouldn't be able to read it. The people that you don't want it to see, which is probably everybody other than the person you sending it to, shouldn't be able to read it. Okay? So encryption is the conversion of something such as data into code or cipher. By encrypting data, you make it unreadable to individuals that shouldn't be able to read it. So if something isn't encrypted, it's referred to as plain text, meaning that if somebody look at it, if somebody get it, they can read it. If something is encrypted, it's called ciphertext, meaning that even if somebody captures it, even if somebody sees it, they shouldn't be able to read it. So we got plain text and ciphertext. Hey gang, in the next video in our series and course, we'll be going through some best practices you and I need to be doing when it comes to our devices. So, of course, you know, when you have any device, whether it's a tablet, whether it's a cell phone, a laptop, a PC, you need to have some form of antivirus or anti-malware. If it connects to the internet, it's susceptible to a lot of viruses. Even if it doesn't connect to the internet, it's susceptible to viruses, but if it connects to the internet, the chance of you getting a virus, you know, is exponentially greater than if it doesn't connect to the internet. So antivirus, not only make sure that you have antivirus, but make sure that the antivirus is up to date. If it's not up to date, if you don't update it regularly, then it's only going to be up to date for the viruses that it knows about. But if you updated it a month ago and 3 weeks ago, a new virus came out, it's going to scan for everything except that virus. Makes sense? Next up, a firewall. We talked about this before. Make sure that you keep the firewall on at all times. So, quick class, we already know that a firewall keeps out the stuff that we don't want, right? So by default, it's going to stop certain things that look suspicious, and then we can actually go in there and configure it to stop things that we know are suspicious. But by default, it's set up pretty good to let through the things that we need and stop the things that we don't need and the things that may be harmful to our device. So passwords, we already know this because you guys are super smart. Make sure that you never keep the default passwords. Always change your passwords. After this, we're actually going to get inside of password best practices, things that we need to do. That's going to be a couple lectures from now. But passwords, make sure that you have a strong password and that you change whatever the hell the default password is. So updates. Make sure that your software is as up to date as possible. When new updates come up, make sure that you update your software. Now, if it's on a personal device, you can probably go and update. But if you're in a production environment, or if you're a system administrator, or if you have a bunch of computers that you need to update, it would behoove you, it would be a good idea for you to run that update in a virtual machine or run that update on a test computer just to see how that update is going to react. Because sometimes updates may not be compatible with your devices, may not be suitable for your devices, and it may actually stop your devices from working. So like I said, most times if it's a personal use thing, it's probably okay just to go ahead and update. But if you're in a larger environment, you want to make sure that you pay attention to that stuff. Okay? All right, so software, whether it's applications, whether it's for PCs, laptops, make sure that when you're using software that it's legitimate, right? So make sure that you're not just picking up CDs or USBs off of the ground and downloading stuff onto your devices, because even if it looks legitimate, right, it may not be legitimate. It may have a back door, it may have a virus embedded into it, it may have a key logger, which is something that's going to actually log your keys. It may have spyware on it, which is something that's going to spy on you and see what you're doing. Just make sure that you get it from a legitimate software or a legitimate source, and just make sure that it's up to snuff, because if not, you may be putting yourself at risk for viruses, identity theft, and a bunch of other stuff you don't really want. Another thing, make sure that you remove anything that you don't want, and remove unnecessary stuff too, because sometimes software and applications may be running in the background. It may be taxing on your CPU, it may be taxing on your RAM, it may be taking up space, and it's something that you don't even need. So a lot of times it's good to do an audit. What applications are running, what applications I need, and if it's stuff that you don't really need, get it out of there. Another thing, if you know you got a virus, pretty much disconnect from your network, right? So you don't propagate that virus, or so it can't replicate, or so it can't get to other devices, and then try to remove that virus as quickly as possible. And then after you do that, come up with some kind of prevention, like, okay, let me make sure that I don't go to that website, or let me make sure that I'm running scans more often, or let me make sure that, you know, this virus isn't embedded anywhere else. But whenever you get a virus, the good thing is, or a good footnote or best practice, is to always get it out of there, get it resolved as soon as possible. Hey gang, in today's video series and course, we're going to actually talk about password best practices. There's some of the things that you need to be doing on any website that you're on. If it has a password, these are the things that you need to ensure that your password has. Ready? Let's get straight into it. So, real simple. If you follow this stuff, you should be okay. Now, main thing, as we go through these passwords and all this best practices, at the bottom is one super duper bit of advice. If you have a super strong password, but you're using it on 50 different sites, it doesn't really matter because once somebody cracks that password, they're going to have access to your email, your bank account, your Facebook, your Instagram. So just make sure that you use different passwords on different sites. And if you just can't remember, because I know every damn thing need a password out, if you just can't remember your passwords, you can actually use a password manager. Pretty much there's a bunch of different applications, there's a bunch of different services that you pretty much say, hey, this is all the stuff that I use, this is all my accounts, and they'll give you one password. So you only got to remember one password, and they'll generate a random password every time you log into those applications. Only downside to that is that if that password manager gets cracked, they got all your stuff. But anyway, there's neither here nor there. Best practices. If you got a password, it needs to be 8 to 12 characters, right? 8 to 12 characters. Anything lower than that, you're kind of asking for trouble. So 8 to 12 characters. If you want it to be more than 12 characters, that's cool, but that's just more shit you got to remember, right? So 8 to 12 characters. Number 2, you should have everything in your password: uppercase, lowercase, numbers, and special characters. And try to avoid things that are in a dictionary. So don't put Nike 1 2 3. Is Nike in a damn dictionary? Hold on, that might have been a bad example. Don't put dog 1 2 3 exclamation point, because that's going to make your password a little bit more susceptible to being cracked. Another thing, try to not have anything that pertains to you, even in your username, or in your password, because a lot of people like to put their last name and then, you know, it'll be Rob85 or Jenkins 72 or whatever, right? So just try to make sure that you don't have anything that pertains to you inside your password or your username, and just make sure that you use all that stuff: uppercase, lowercase, special characters, and numbers, and try to avoid anything that's in the dictionary, any words that's in the dictionary. Another thing, like I said before, passwords shouldn't be repeated. Most systems now won't allow you to reuse the same password, because a lot of times passwords have expiration dates, whether you got to change it every 60 days, every 90 days, every 180 days, whatever it is. Most places have an expiration date on your password. So make sure that if it is a system that you can reuse your password, that you don't reuse the same password, because that's going to make you more susceptible to get your password cracked, because that password, you probably written that password down somewhere, probably got it saved in your phone. So just make sure that you don't reuse passwords. And then, like I was saying at the beginning, make sure that you don't use the same password across several platforms, because like I said, when somebody cracks your password, they're going to try to use that password across multiple platforms. Make sense? All right, guys, so this is the last video in our series and course, and we're going to talk about continuity concepts. Continuity just means that the continuation, right? The continuation, if something happens, how we can continue on, how we can keep on serving users, how we can continue to keep on doing what we need to do. Continuity concepts, this is really important for businesses, whether it's Master IT, whether it's Google, whether it's YouTube, continuity. If something goes wrong, if something doesn't work the way we want it to, how do we recover from those things? Okay. So fault tolerance. Every business, everybody wants to have fault tolerance, meaning that how tolerant are we when something breaks? How quickly can we bounce back when something breaks? How quickly can we fix errors? All right. So the more fault tolerant that you are, the better that you'll be. So how to strengthen your fault tolerance? You can do that through redundancy and backups. Redundancy just means the same thing over and over and over and over again. The reason that you can actually increase your fault tolerance through backups is that if you have a fault, a terrible fault that erases everything, that corrupts everything, you have backups. So it's not going to take you that long to come back online. Instead of having to rewrite everything, having to rebuild everything, you have backups of the things that you need. Okay. So there's a couple different types of backups. A full backup is a whole shebang bang. That is everything, right? That may be a terabyte, that may be a zettabyte, that may be just a ridiculous amount of information. So most times if you need to do a full backup, if you're in a production environment or if you're even doing your personal backup, you need to do that at a time that you're not really going to be on the computer. So pretty much you let it back up overnight, or you let it back up for a couple nights, or you just pretty much tell everybody, hey, it's going to be a network outage, or this isn't going to work, so on and so forth. So you just have a designated block of time to where you can back up your stuff, because you don't want to be moving stuff around and certain stuff doesn't get backed up, or it stops the backup at all because it couldn't access certain things. Okay. Now you have a differential backup. So a differential backup is a type of backup that copies all the data that has changed since the last full backup. Okay. So only thing it's going to save, instead of doing a whole shebang bang, if you had a gigabyte worth of information and you added 2 files, with a differential backup, it's not going to back up the whole 1 gigabyte. It's only going to save those 2 files and add those to the original 1 gigabyte backup. Okay. So differential. Then you have incremental. Incremental captures only the changes made since the last incremental backup. Okay. So full backup, whole shebang bang. Differential only saves the stuff since the last full backup. Then the incremental only saves the stuff from the last incremental backup. All right. And all of this stuff, like I said, improves fault tolerance and creates redundancy. So you have the same file saved over and over again. So if you lose it, you always have those backups. Now, another thing that's going to help with fault tolerance is disaster recovery, whether it be man-made, whether it be a malicious attack, but just when things happen, how fast can we recover, right? So there's a couple different sites that we can have, whether it be cloud-based or whether it be a physical location. But these are the different sites that most businesses would set up, and it depends on their size, their budget and stuff like that, what type of recovery site they'll have. So a cold site is usually just another building. Meaning that if this damn building set on fire, at least we'll have another building. It may not have no equipment, it may not have nothing in there, but usually the electricity is on, water is running, stuff like that. But it's just another building that, we can start from scratch and go over there. Now, a warm site has some of the same capabilities as the main site that was destroyed, but it doesn't have everything, right? It may have a couple servers, but at our main site we have 30 servers. It may have 20 PCs, but we got 100 employees. So it's just got some of the stuff, right? Now, a hot site means that it's an exact replica. Whatever the hell was at our main site, we can literally, if our main site is here, our hot site is here, we can go across the street and it's going to be a mirror image. Whatever we could do at our main site, we can do it at our hot site. Now, of course, the hot site is going to be the most time consuming and the most expensive, but it's going to be able to get you back on your feet as fast as possible. Now, each site and each business has a different order of restoration, right? And another thing, like we talked about a couple episodes before, is that with fault tolerance, with disaster recovery, power outages, that's one of the biggest things, right? to save the information that's on your servers, to save the information that's on your most important devices, you always want to have them connected to an UPS, or an uninterrupted power supply, right? So that UPS is used as a backup, somewhat of a backup generator, but just backup power just to those main devices. And the main thing is just to save everything, because some UPS may last 30 minutes, some may last 6 hours. But the main thing is just, okay, let me make sure that everything is saved, everything is backed up, and I can shut it down properly so nothing is corrupted, right? So for a site, it may be, okay, let me make sure the UPS is on, let me make sure the main power then turn back on, and then let me make sure that the servers is up, right? Or it may be, okay, the UPS is on, main power ain't working, let me save everything and shut down properly, right? So depending on your site and depending on your modus operandi, or what you actually do at your business, depends on what's going to be a priority as far as what should we restore first, what should we get back online first.